Welcome back to software engineering. Today we're going to look at what ultimately becomes a fan favorite for everybody, the UML class diagram. You'll see a lot of these in your profession. I think they're pretty much unavoidable. So while your first impression is probably going to be, wow, that's dumb, you're not going to be able to avoid these. So you're probably going to be better off just learning them. Let's see. Going to do a little stream check real quick. I'm having YouTube telling me that I don't have any viewers left, so let's see if I'm maybe wrong there. It can take a while to update. Oh, alright, looks like it's up. There we go. Alright, so yeah, unavoidable part of working in the software industry unless you work at a really small shop or somewhere where you're making software, but it's not necessarily a software development firm. And even in those cases, you'll probably end up with UML. Now, UML probably stands for Unified Modeling Language, but you'll hear other very similar abbreviations like Universal Modeling Language, etc. So don't worry about it. Anyway, everyone just refers to it as UML. And when people say UML diagram, they usually mean class diagram, although technically you're supposed to be more specific because there's other kinds like the use case and the activity and everything. But most people, when they say UML diagram, they mean a class diagram. So how do people draw or write down software architecture? Many of you have come up with your own format, and that is exactly the problem, that for a long time, before UML was invented in 95 or so, people all used their own different formats to describe software, and it was irritating because you had to learn somebody else's format in order to talk about their software. And we have a lot of that in this industry, a lack of standardization of our different practices. That's basically par for the course in this industry. So luckily we've got this one format, this UML class diagram format that most people are familiar with. And this is really one of the only ones that kind of spans different industries. So software engineers who work in, I don't know, chemical engineering or web development or whatever, they'll all be familiar with it. That's not true of almost anything else in software, unfortunately. So don't ruin it by deciding that you've got your own better format, okay? Stick to the program here. This is one of the best things we've done as an industry, is coming up with a format for something. So use it. All right, some example architectures perhaps we might come up with. We might come up with this architecture where there's like an inheritance structure. You have a very particular kind of student, and maybe a less particular kind of student, and then that's obviously a person, a amphibious thing that lives in a lake, that lives in the sea, etc. It doesn't really matter. Okay, so what is UML? Why should you bother? Do people really use it? Yes, you should bother, and yes, people do really use it. What is a UML class diagram? You're about to find out. Let's see. So we've talked about the design phase already. We're trying to specify the structure of how a software system will be written and function. We are not writing code at this point, but we are writing the outline of what the code will look like, essentially, or what we think it'll look like at this point. And as agile developers, we realize that this process will be iterative, and what we write down will probably change to an extent, but we want to be as accurate as possible in this phase, even though we're going to iterate on it later. So we're transitioning from our requirements phase, where we described what the system will do, to a more specific and how-based document where we actually explain how the system will do what we said it'll do. And again, sometimes these steps run concurrently, the requirements and the design. So we're talking about like what classes are we going to need, what fields and methods will these classes have, how will those classes talk to each other. We're talking about composition, we're talking about inheritance, we're talking about polymorphism, we're talking about everything you were supposed to learn in 129. You did learn all those things, didn't you? All right, how do we design classes? Well, we got our class identification. That's probably going to come from our project specification to an extent. Anything that we see in the requirements document that looks like a noun might end up being a class, might not. But that's a good starting point. Look at the nouns. See which nouns can become classes. Maybe one noun can be multiple classes, but that's a good starting point. Likewise, look at the verbs. The verbs might be methods. They might be responsibilities that are implemented maybe in a more complicated way than just one single method, but they're probably going to be methods of some kind, all the verbs. So not a surefire solution, but a good starting point. So a good exercise you might want to take to get started is to write down all the different classes names you think of. We've already done this portion, so you've already got it. And then let's say you follow that up by taking that list of classes you wrote down and try writing down the responsibilities that that class will have next to it. Use short verb phrases, maybe pulled from your requirements, and then write down what other classes, what other nouns it's going to have to interact with. So what collaborations it's going to do, and what kind of messages it's going to send to that other collaborator there. And then that's eventually going to bring us to our UML diagrams, and you can also make things like sequence diagrams and activity diagrams, which we made already, to better understand the program's flow. So while the UML class diagram is going to describe its structure, the flow is also important, and we might describe that with activity and sequence diagrams. So the structure is going to get us our logical view, and then if we want to talk about the flow and how it executes and how users go through it and all this different stuff, that would go into the process view, and that'd be composed of sequence diagrams and such. So you've started that a little, but today we're going to be more concerned about the class diagrams and the structure. So UML, basically just pictures of an object-oriented system. We don't want to just write in code because that's not abstract enough. But programming languages can't get you infinite abstraction. There are limitations to every programming language, so you have to kind of be aware of what language you've chosen, or at least what family of languages you've chosen. You don't have the same kind of inheritance capabilities in C as you might in Java, for example, at least not in the normal way that that language is used. UML is an open standard that many companies use, again, so useful to know. Legal UML we're not going to go into here, but some organizations will use a much more formal UML for something like contracting or delivering a bid to the customer. So it might be part of the requirements document, a more formal UML, but we're not going to do that here. Okay, so why would you use UML? So you could use it as a sketch, which is kind of our application here. We're going to try to evaluate the system roughly, just get some ideas basically. This is usually done as a very informal practice, which is kind of how we're doing it here. Now, you might use UML more strictly as an actual blueprint for how your developers have to do everything, which is also to an extent how we're going to do it, because after you've built the class diagrams and everything, the next team that takes over is going to use that blueprint that you made to develop the application, and they are going to have to follow it. Sometimes, when we do it this way, we use computer-assisted tools to actually generate the UML from our existing code, which is a little bit like cheating. But if you think about the agile process and the fact that we're constantly iterating, if our UML diagrams are constantly changing, then it becomes somebody's job to keep updating them. That is, of course, cumbersome, and so it's much easier to automatically generate them from your existing code. So tools like that are very helpful. And then as a programming language, this point is kind of a dream. It's not really done in practice, but if your UML was specific enough, perhaps you could automatically generate the code just from the UML. In practice, this is pretty much impossible for anything but the simplest of applications. But maybe one day we won't have to write code. We'll just write UML, and then the AI will figure out the rest. That would be neat, wouldn't it? So look at a little bit of history. Before UML comes in and standardizes, we had a few different approaches. We had Booch and OML and OC and others and blah, blah, blah. And then in the 90s, they come together and bring us the UML standard, which, didn't it stand for Unified Modeling Language? No, it stands for Union of All Modeling Languages. It's one of those things. Anyway, it was a combination of all those different standards. That's why we have a bunch of different diagrams. We've gone over almost all of these: the use case, sequence, activity, Now we're going to look at class and component. So you've got a lot of different diagrams in the UML standard. Let's look at a object diagram before we look at a true UML diagram. So you see obviously this is in sketch form, and this is a much rougher diagram than what I expect you to do today. Here you might just have individual objects in a heap layout. You have the object's name, maybe a type, maybe an attribute, and then you have lines between them to show how they reference one another. So this would be a real simple object here. Let's look at the class diagram next, the summary of all possible object diagrams. Here's a fancier, less sketched version of an object diagram, but again, we're not doing these today, we're doing class diagrams. So class diagrams are a picture of your different classes in an OO system. So again, from 129, you should all be familiar with these terms, the term class, field, and method. Fields you might have heard referred to as instance variables instead, depending on who you had 129 with. A field is the variables at the top of the class, if that still hasn't clicked for you. So the classes is, the class files, you have to know that one. The fields are the variables at the top. They could be public, they could be private, remember, right? And then methods, of course, are the functions that the class has. And you've got connections between the classes. Your fields could be classes, right? You can have, let's say you have a class called doodad, and you have another class called widget. A widget can have a field that is a doodad. That's composition. So you could have that. You could also have inheritance. You could have a class called pet, and pet could have a subclass called dog. Dog inherits from pet. That's inheritance. So you have different relationships between classes. Those are expressed visually using different kinds of lines. What's not represented in the UML class diagram? So details of how the classes interact is not included. Whether or not a class is a field, a subclass, or some other kind of relationship usually is, but not always. There are less detailed UML diagrams where even that's not expressed. But details beyond that of how the classes interact, like what they actually do to speak to one another, that is not represented. And we also don't talk about how the code does anything. So if we have a method that, say, calculates the square root, we would just say something like function square root. We would not say how it finds the square root or anything like that. That's not important here. We're just dictating what that method might have. So this might be familiar to you as kind of an interface concept. So the same concept as interfaces. You specify what methods that a class has without specifying how they work. Okay, so you can kind of equate it to that. Although here you're also specifying fields. And as I'll show you later, there's actually a different way to represent interfaces in UML. So little basics on the syntax. You get a box for each class, okay? The box has the class name at the top, usually in a larger font, usually bold. If it's an interface, like I said, different syntax, you write interface at the top in the little brackets. Some formats will also have different specifications besides interface, and that can vary by language. Then you're going to use italics for an abstract class. Most of you probably won't want to use abstract classes, but perhaps you will. I don't know. Hopefully you learned about those in 129 too. Then you've got your attributes, fields, right? So include all the fields. You've got minus signs and plus signs and hashtags and tildes representing public and private and protected, etc. I think there's a slide on that later, so I'll go back to that. Then you've got your methods, functions, operations, whatever you want to call them. Typically, we omit getters and setters, even if we specify that a field was private above. So if it needs to be gotten, we'll figure that out. You don't need to write the get everything in there. However, you see in the example given here in student has a name, and they still included get name. So you can. It just depends on the size of the box and how trivial you think that the method is, whether or not you want to omit it. And we don't want to include inherited methods. So if we had a subclass of rectangle, let's say rectangle is a subclass of quad, it's going to inherit a bunch of things from quad, and we wouldn't put any of those in rectangle. We would just put those in quad and show that the rectangle inherits from quad, and then if you wanted to see what it inherits, Well, you could simply look at quad. Okay, so back to those symbols for visibility, plus for public, pound, hashtag, whatever you want to call it for protected, a hyphen for private or a minus for private, tilde for the default. In Java, that's the package private, similar to protected, similar to public. For your purposes, everything will probably be public or private since we really don't teach you about protected or package here, and basically everything we do, even in this class, is going to be a one package wonder. You don't really do multiple package projects here. Those are more for obviously larger scale work. So go ahead and use plus and minus for pretty much everything, unless you have a compelling reason not to. Going to something like swing, for example, which some of you probably learned in 129, you've got your paint component method, which obviously has to be protected because that's how Java specified that it must be. So there's one example where you might use the protected one. Derived attributes, not stored, but can be computed from other attribute fields. Ooh, interesting. So sounds complicated, but actually really straightforward. If you have attributes that you specify, like width and height, then there's kind of an implied attribute that might be important called area. You might want to include it in the UML diagram, even if you don't plan for it to be a field. So by indicating with that dash that it's a derived attribute, you're kind of indicating this shouldn't really be a field, but it should be something that the object keeps track of. Maybe it's got a getter method, whatever. So area can be derived from width and height, but you don't store it separately. All right, how to say methods. Same syntax for the protection, so the plussing, the minusing for public and private. Then you also want to underline your static methods. What do you do if a field is static? Same thing. It's kind of weird they didn't, oh, they actually did specify it here. I just forgot to say it. So fields, also if they're static, get underlined. Hopefully we all remember what static means from 129 too, right? Static means there's one copy of a method, one copy of a field that all objects of that type share. You will normally list your parameters, but you don't give them names or variable names, just like for the variables. We listed there, or not like for the variables, sorry. For the variables, we listed a proposed name for them, and then also the type. For the local arguments for the methods, we just have to list the type. So getID takes an int. We don't say that it takes an int n, even though obviously in Java we have to give our variables a name. The name of the local variable doesn't matter, and the developer would probably just use a simple placeholder there anyway. So for the method arguments, you just list the type. So if you took 3 strings, it'd just be string, string, string. You can omit return type, obviously, on a constructor, which doesn't have any, and you could also omit return type if a method was void. Otherwise, you would have to put the return type there. And let's see, if you did want to write some detail for some reason, again, we don't want to talk about implementation details, but if there's other details that you wanted to discuss or address for future programmers, then you could add comments using your comment tool, and those are typically added using the folded note that almost any text editor will support. Okay, I will read you to read the rest yourselves about the relationship between classes and how to portray those things. The one thing I'm going to point out, there's the different classes of lines between different kinds of hierarchies. There's the multiplicity for how many of an object are used, 0 or 1, 1 exactly, between 2 and 4 inclusive, and many, which is usually written as 3 ... So if you have 1,000 object records, then there would be 3 ... of them, or 3 ... star of them. That is many. Multiplicity of associations, aggregation. Okay, so composition, which you might not be super familiar with coming from 129. So there's total aggregation, that is, you are a part of, one class is a part of another. There's composition is entirely made of, that's wholly dependent. This usually means that the other class is a field of this one. So for example, a book is made up of pages. That means in the book class, there's probably something like an array of pages. There are multiple pages, so you do the 3 star or star to indicate that there are multiple pages in an array, perhaps. When the book is destroyed, the pages are also destroyed. The book is wholly comprised of pages. Pages live and die along with their book that they belong to. So then they are composed of it. And dependency that is used only temporarily would be indicated with a dotted line, so some things come and go. This is more appropriate for applications where something gets passed around to many different objects but doesn't stay on that object. It might visit a method from one object, something happens to it, and then it goes elsewhere. That's an example of a temporary dependency. Let's look at one more composition aggregation example before we close for the day, and I leave you to it. So the movie theater relationship with the movie and the box office. So the box office is an example of composition, and then the movie is an example of aggregation, because when the movie theater is destroyed, there is no more box office. They are intrinsically linked. So the movie theater probably has a reference to the box office. Maybe the box office is a field of the movie theater. They're also one-to-one. There's one box office for every one movie theater, whereas for movies, there are many, so it's a one-to-many relationship between movies and movie theaters. There are many movies for each movie theater. And the movies remain even when a movie theater is destroyed. So if there is no movie theater, then there is no box office, but the movies remain, and they might still interact with other movie theaters, since there might be many movie theaters, each with a one-to-one relationship to box office, that interact with the different movies that there are in play. So with the box office, it has a composition relationship. With movies, it has an aggregation relationship. So something to think about. And if you want to learn more about this kind of stuff, don't forget to take the design patterns class next time we offer it, probably next year or so. All right, I'll leave you to it. And yeah, you might get a visit from your manager, Mr. Bob, today to ask you why you're not finished. And feel free to call the customer if you want. Remember that you also still have to maintain your requirements document as you go. So make sure you keep that up to date too as you work on this UML diagram. You might uncover certain, certain things that you want to add or remove from your requirements. Who knows? Okay. See you in Discord.